welcome to our presentation. Today, we will be showcasing our natural water filter. We will explain how system works, why we selected specific materials, the scientific principle behind each layer, and the quantitative data that demonstrate its effects. By the end, you will see clear connection between our design and the improvement in water quality.
A few moments later.
This is the full setup of our filtration unit. We constructed it using recycled plastic bottles stacked vertically. Inside the filter is arranged with layered materials such as coarse gravel, small gravel, coarse sand, charcoal, fine sand, and cloth. These layers were chosen to simulate real-world filtration used in environmental engineering and natural ecosystem. When we tested the prototype using contaminated water collected from a stagnant water source, the filter output was visibly clearer. We observed a significant decrease in suspended particles. This is supported by our turbidity measurements, which dropped from high cloudiness to a much lower level. We also recorded improvements in BOD, indicating that the biological oxygen demand decreased after filtration. This confirms that organic contaminants were reduced, not just physically removed.
Our system prioritizes sustainability. We choose recycled bottle as the main structure to reduce plastic waste. The gravel and sands were sourced from natural surroundings, cleaned and reused. Charcoal was selected because it is a low-cost, highly effective absorbent and can be produced from the biomass. Our design is not only functional but also highly accessible, making it ideal for low-resource settings or emergency use. The order of the layers follow a logical filtration sequence. The top gravel removed larger debris, while the smaller gravel improved trapping efficiency. Coarse sand and fine sand remove finer particles and increasing clarity. Charcoal sits in the middle because it performs chemical absorption, removing dissolved impurities and odor-causing molecules. Finally, cloth acts as a microfilter to catch any final sediments before the water exits.
The filtration system operates through three main scientific mechanisms. Firstly, physical filtrations. Gravel and sand trap suspend solid through sieving, sedimentations, and depth filtrations. As water percolates downwards, particles become lodged among grains, reducing turbidity. Second is chemical filtrations. Charcoal provides adsorptions. Its burrows structured by organic compounds, chlorine, dyes, and other molecules. This step is crucial for lowering BOD and improving smell and taste. Third is biological filtrations. Over time, beneficial organisms colonize the charcoal and sands. These microbes help break down organic matter, contributing to BOD reduction and improve dissolved oxygen level. This combined process mimics natural groundwater filtrations.
We recorded several parameters before and after filtration. Using a turbidity meter, we saw a large drop in turbidity values. Using DO and BOD measurement, we detect an improvement in oxygen level and reduced biological oxygen demand. We also measured pH, which shifted slightly toward neutral, indicating a more balanced water condition. Flow rate was measured using a time volume method.
Our results are summarized in organized tables and graphs. The turbidity graph shows a clear downward trend. The BOD bar chart shows reduced organic load. The DO comparison demonstrates improved oxygen concentration. These results align with our expectation based on the scientific principles. The data confirms that each layer contributed to the overall filtration efficiency.
Here we pour the contaminated water into the top of the filter. Notice how the water flows through each layer. As it exits at the bottom, you can immediately see that the water is clearer. This visual change is backed by the quantitative data we recorded earlier.
Thank you for watching our filtration prototype successfully reduce contaminants using sustainable materials, strong scientific principles, and measurable data. We hope these demonstrations offer clear insights into low-cost and eco-friendly water purification methods.